Okay, let's continue the discussion of the hyperbola. In this video, we are going to move hyperbola. We are going to move the center to the point HK. So analyze hyperbolas with center HK. So after we discuss the parabola ellipse, to discuss this moment for hyperbola will be easier because we already had two examples. For the parabola, we talk about the vertex. For the ellipse, we talk about the center. Hyperbola also has a center. If, for example, let's talk about the horizontal case. If we have this, then if we have this first standard position, then the equation is x squared over a squared minus y squared over b squared. Here the c here is negative c. This is a. This is negative a. Then a squared plus b squared is equal to c squared. Okay, this is a relation. And if the center is 0, 0. If we move the center to HK, to the point HK, the equation becomes x minus h squared over a squared minus y minus k squared over b squared is equal to a. So the movement again only affect x part and the y part. A and B does not affect because the basic structure does not change. You just change the position. Okay, so this is a horizontal case. If we have vertical case, negative A, positive A, C, negative C. If you have vertical case, again, we move the center to HK, the equation becomes y minus k, hk, so y minus k over a squared minus x minus h over b squared is equal to 1. Okay, exactly the same behavior. X minus h, y minus k. And again, a squared plus b squared is equal to c squared. Okay, so that's the same similar thing. Let's see the example. Write equation or find an equation of the parabola. I'm sorry, hyperbola with center at 1, negative 2, 1 focus at 4, negative 2, and 1 vertex at 3, negative 2. Okay, so center, focus, vertex. Center give you HK. Focus and vertex will give you A and C. Okay, focus will give you C. Vertex will give you A. So this is directly related to C and this is directly related to A. But how? Let's draw the graph. We don't discuss it in an abstract way. How this case, that case. We always check it based on the graph. Okay, so let's try to sketch it. So it's a 1, -2, 4, -2, 3, -2. It's horizontal. So let's check. 1, 2, 3, 4. Okay, 1, 2, -2. 1, -2 is here. This is 1, -2, the center. Focus 4, -2. This is F. 1, 2, 3, 4. -1, -2. This is a focus. Vertex 3, -2. Here's a vertex 3, -2. When I have vertex, it looks like this. Center is here. Then what is A? A is the distance between the vertex and the center. This is A. 3 minus 1 is equal to 2. What is a C? C is the distance between the center and the focus. 4 minus 1, 3. Okay, it's horizontal. It's horizontal. X comes first. And C is 3. A is 2. So A squared plus B squared is equal to C squared. A is 2. So 2 squared plus B squared is equal to 3 squared, 9. So B squared is 5. Okay, so A is here. 5 is here. Horizontal, again, it is X. The first term is X. X minus the center, 1 square. Y minus -2 square is equal to 1. Because this transverse axis is parallel to the x-axis, so the x comes first. And you have A, B. Always first one is A, second one is B. That's the fixed setting. First is A, second is B. Okay, so this is A, this is B. A squared, B squared. Okay, so you don't, I mean, we cannot just based on those quantities to determine the equation. We have to draw it. After we draw it, all the quantities will be clear. Right? That's our first example. Second example. Analyze the equation. The equation is -x squared plus 4y squared minus 2x minus 16y plus 11 equal to 0. So whenever you see this analyze problem, especially for the parabola, ellipse, hyperbola, you always complete square for the square term. Always do that. So to complete square, we first move x 11 to the right side. We combine x term together and the y term together. So we get -x squared minus 2x, 4y squared minus 16y is equal to 11. So first you group them like this, and second you factor out x negative sign. You get x squared plus 2x. 2 over 2 is 1, so you need to add 1 square. Remember that we had this trick in the last video. So you divide this 2 by this coefficient by 2, you will get a. Then this is a squared. Plus here you factor out 4, you get y squared minus 4y. You divide 4 by 2, you get 2. A is equal to 2, then you put 2 squared is 4. And then let's check. You put 1 inside the parentheses, you have -1. This is -1. So, oh, sorry, this is -11. -11, you copy it. Here you -1, then this is -1. You put 4 inside the parentheses, so 4 times 4 is 16, so you add 16. Okay, so you move here, this is -11. This is -11 minus 1. Minus 1 comes from this -1. And plus 16, because here 4 times 4 is 16. Okay, so this becomes x plus 1 squared. This is 4y minus 2 squared is equal to, this is Negative 12 plus 16 is 4. We divide this equation by this 4, this constant. We want to make the right side 1. And also we choose the positive term first. So we get y minus 2 squared minus x plus 1 squared over 4 is equal to 1. Okay, so y term comes first. So this parabola is vertical. So not parabola, my bad, hyperbola. This hyperbola is vertical. The two foci are parallel to the y-axis. Okay, so let's read it. The center is at here x plus 1, x minus negative 1. The center is at negative 1 and 2. And a is 1. A is the denominator of the first of the positive term. A squared is the denominator of the positive term. So a is 1. B squared is 4, so b is 2. A is 1, b is 2. So c squared is a squared plus b squared is 1 plus 4 is 5. So c is square root of 5. Okay. Now let's try to sketch it. Negative 1 and 2. Negative 1 and 2. This is a point. Remember, it's vertical because y comes first. C is negative. C is the square root of 5. It means you will go up square root of 5 unit. So this is a 2 plus square root of 5. This point is 2 plus square root of 5. And then you go down square root of 5 unit. This is 2 minus square root of 5. This one, negative 1. Let's put a negative 1 here. 2 minus square root of 5. So this is a focus and a focus. So the foci are at negative 1, 2 plus square root of 5, and negative 1, 2 minus square root of 5. This is foci. Vertices. Vertices are related to A. A is 2, so A is 2. So 2 plus 2, this is a 4. And 2 minus 2, 2 minus 2, this is 0. So vertices are at negative 1, 2 plus 2, 4. And negative 1, 2 minus 2, 0. This is vertices. So we have center, foci, vertices. And for the hyperbola, there are two oblique asymptotes. What are the oblique asymptotes? Remember, how do we do that? This is the equation. We just write y minus 2 over a over 1 minus x plus 1 over 2 equal to 0. Remember how we did it? We drop the square, we drop the 1, change it to be 0, and we put a negative sign, and we also put positive sign. This is a oblique asymptote. If you want, you can write it in the standard way, or you just leave it like this. This is good enough for the exam. Okay, it's perfect enough for the exam. So this is asymptotes. Asymptotes. Okay, so that's a reasonable analysis. The reasonable analysis. You have a center, foci, vertices, asymptotes. These are the important information about hyperbola. Okay? Let's do more example. This is always a tricky one. Let's have this example. Foci at 3, 7 and 7, 7. Vertex, one vertex at 6, 7. We're looking for the equation of the of hyperbola. Okay, so let's check it. So height is 7. It's very tall. 1, 2, 3, 4, 5, 6, 7. Okay, 7 is right. 1, 2, 3, 4, 5, 6, 7. This is 7. This is 7. Foci at 3, 7. 1, 2, 1, 2, 3, 3, 7. This is foci. One foci. One focus. Another 7, 7. 7, 7 is here. Another. Okay. And one vertex is a 6, 7. This is 6, 7. It's F1, F2. This is V2. V1 is here. Okay, so horizontal. The transverse axis is parallel to the x-axis. The transverse axis is parallel to the x-axis. So x term comes first. Whenever it's parallel to the x-axis, x comes first. Let's look at the center. Where's the center? 3, 7. This is 7, this is a 3. The midterm is 5. So the center is 5, 7. How do I get 5? 3 plus 7 over 2. 3 plus 7 over 2, that's a 5, the midpoint. They are horizontal, so the y coordinate is also 7. That's the center. Once we get the center, let's see what is C and what is A. The distance between the center and the focus is C. C is equal to 2. And the distance between the center and the vertex is A. So A is equal to 1. This is 6, this is 5, this is 7. Okay? So A is equal to 1, C is equal to 2. A squared plus B squared is equal to C squared. So it's 1 squared plus B squared is equal to 2 squared. So B squared is equal to 3. Good. B squared is equal to 3. Now let's write down the equation. What is the equation? A squared comes first, 1, minus B squared comes second, 3. And because it's horizontal, it's x. X comes first. X minus 5 squared. Y minus 7 squared is equal to 1. So you can write this way. You can write it this way. Okay? So that's the equation. Okay. For this case, there's one small geometric information I want to discuss. Maybe it's helpful for some problem. For this equation, for this hyperbola, what is asymptote? Asymptote. Check here. Okay, this is asymptote. if we simplify it, or if we write it like the slope times x plus something, like slope-intercept form, we will see that, for example, we move this to the right side and explain, do something a little bit. And you will see that y is equal to b over a times x minus h and plus k. So the coefficient, this is coefficient b over a. The coefficient for the horizontal one, the slope is b over a. If we do this one in a similar way, we will get, let me write it. Negative x minus h over a. So y minus k is negative b over a x minus h, and y is negative b over a x minus h plus k. So the slopes of two oblique asymptotes are tightly related to the ratio of a b over a. This is for the horizontal one. If a vertical one is a over b. But anyway, you just keep in mind the slopes have the information. The slopes have the information about a and b. Let's see if we can use it or we don't need to use it. Another example. So vertices at 1, negative 3, and 1, 1. It's negative 3. This is a 1. This is a 1, 1, 1, negative 3. Okay, so the vertex is vertical, so y term comes first. Y term comes first. And the midpoint, negative 3 plus 1 divided by 2 is negative 1. So the midpoint, this is a center. The center is the midpoint of two vertices. It is also the midpoint of two foci. So you can use either of them to determine the center. The center is negative, is a 1, negative 1. The x coordinate is always 1. The y coordinate, the height is negative 1. Okay, this is the center. When you have the center, a is equal to 2. So from 1 to negative 1, the distance is 2. Vertical distance is 2. So a is equal to 2. Okay, that's it. And now let's check. It's a vertical, so it's a y minus negative 1 squared over 4 minus x minus 1 squared over b squared is equal to 1. Okay, so far we don't have foci. If there's no foci, there are no foci, you don't have c. No c, you cannot directly find out b squared. Remember, this is a relation about a, b, c. You only have a, then the b depends on c, but we don't know c, so we have to put b here. And it's vertical, so y comes first. Y comes first. Now let's check. How do we know what is b? So that's the next condition. Asymptotes. Asymptote, the line y plus 1 equal to 3 halves x minus 1. This is the second condition. Vertices condition and the asymptote condition. Now let's look at the asymptote from this one. So y minus negative 1 is y plus 1. Y plus 1 over 2. It's not over 4, it's over 2. Minus x minus 1 over b equal to 0. Or y plus 1 over 2 plus x minus 1 over b equal to 0. So from here, let's move this to the right side. So y plus 1 over 2 is x minus 1 over b. Y plus 1, move 2 to the right side, 2 over b, x minus 1. So y is 2 over b, x minus 1, and minus 1. And this one, we do the similar steps. And y is equal to negative 2 over bx minus 1 minus 1. So you compare, I don't need this, I need this one, these two. To compare these two with the asymptotes, so it's a y plus 1, 3 over 2x minus 1. Here's a here's a y plus 1, 2 over bx minus 1. So you get 2 over b is 3 over 2 is equal to 3 over 2. 2 over b is a 3 over 2. You solve it, you get b is what? 4 over 3. B is 4 over 3. Okay, so B is a 4 over 3. That's done. So the equation is y plus 1 squared over 4 minus x minus 1 squared over b squared, 16 over 9 is equal to 1. The denominator is 16 over 9. Well, we never say the denominator cannot be a rational number. It can be whatever positive number. Even you can put pi there. Okay? So it's just, it depends on this problem. Here, this problem give you b 4 over 3, then 4 over 3 squared is 16 over 9. It will be in the denominator part. Don't simplify it. Don't simplify it. This is the answer. Okay, so this is a method to use the asymptote find the equation of the parabola. And asymptote, how do you get asymptote? Remove the square, especially don't forget to remove the square of the denominator. Okay, remove square, change 1 to be 0 and find the right two steps. Write two different lines to find the two different asymptotes. Okay, so there are many interesting practice in this section. Do exercise, make sure you understand all the steps. And if you have a question, you must ask. Okay, it's a fixed protocol machinery problem, but still it requires some computation. Okay, so we stop this video and we will start another video.